Welcome, focused learners, to this explainer. Think of me as your managing director today, and right now we are stepping straight into the executive boardroom. Our client brief for this session, the Cambridge AS and A-Level Mathematics 9709 exam. And the core assets we need to leverage to win this account? Newton's laws of motion. Specifically, the mechanics of F equals ma and weight W equals mg. You know, most candidates approach these past papers like junior data entry clerks. They literally just plug numbers into a calculator and hope for the best. But to secure the absolute highest tariff marks, you need to structure your exam responses with the clarity, the authority, and the strategic precision of an executive consultant. Let me introduce you to two archetypes I see all the time. First, we have consultant Alex. Alex has excellent raw data points in their head, but their delivery and executive summary on paper, total chaos. Then we have consultant Sam. Sam is a highly persuasive speaker, very confident, but completely lacks the physical asset and case study backing to prove their point. By the end of this masterclass, we are going to audit your current approach and make sure you aren't an Alex or a Sam. We are going to transform your work into a high-scoring, structurally flawless presentation. Let's get to work. Okay, let's dive into this incredibly revealing quote straight from the principal examiner reports. Even if your final answer is wrong, method marks can save you. Now think about that for a second. In the corporate consulting world, we have a saying, you don't just bill for the final product, you bill for the methodology. The exact same principle applies to your Cambridge math exams. We call this the method mark strategy. It is a massive misconception that examiners only care about that flawless, final numerical answer sitting at the bottom of the page. No way. They are actively looking, almost desperate really, to award you points for your process, your logic, and your systematic working. If you hide your methodology, you are literally leaving money, or in this case, marks, on the table.
So, I have to ask you directly, are you losing easy marks on Newton's laws? Like I mentioned earlier, I see so many incredibly bright students, our consultant Alex types, who actually know the math. They have the raw mathematical data down cold. But because their execution on paper is so unorganized, they completely drop vital points. They fail to communicate their structural strategy to the examiner. I really want you to shift your mindset right here, right now. Stop stressing exclusively over getting a perfect error-free final calculation. Actually, scratch that. Obviously, you want the right answer, but start actively planning how to strategically secure every single methodological point along the way. That's your insurance policy.
To achieve this executive-level clarity, here's our structural roadmap for today's explainer. First up, we're going to master the core principles. Next, we'll look at executing the procedural framework, and finally, we will conduct a live audit of the top 3 examiner traps.
Section 1. Mastering the core principles, building the theoretical architecture. We are laying the concrete foundation right here. Because let me tell you, rote memorization simply isn't enough to pass compliance standards for those top-tier grades.
Now, what's absolutely crucial about this fundamental distinction between mass and weight is that it's where our consultant Sam types usually fail. They sound confident, but they lack the technical backing. It seems basic, right? But the principal examiner reports show that students consistently conflate the two. Mass, the m in F equals ma, is a scalar quantity. It is your baseline physical property. It doesn't change whether you're in this boardroom or on the moon. Weight, however, the w in W equals mg, is a force. It's a vector that is entirely dependent on the gravitational field. If you fail to clearly define these parameters and their causal relationships in your working, your entire analytical framework collapses. The examiner needs to see that you fundamentally understand the physics and the mechanics, not just how to shuffle algebra around.
In the boardroom, we have strict compliance standards. For your Cambridge exams, those are your assessment objectives. Let's call them AO1, AO2, and AO3. They are specifically designed to target 3 distinct cognitive domains. First, your knowledge and understanding of the terminology. Second, the application of relevant principles to brand new contexts. And third, critical analysis of the data provided. Listen, if your written response only demonstrates knowledge, but you totally fail to apply it or analyze the broader situation, you are leaving high tariff marks entirely out of reach. You have to prove your competency across all 3 of these domains to close the deal.
And here is the secret weapon. This is what separates an average, everyday student from a top-tier elite performer. It's cross-topic connections. The examiners explicitly noted that candidates who integrate Newton's laws with other syllabus areas achieve significantly higher marks. What does that look like? It means tying kinematics equations into a force problem or seamlessly linking energy and work concepts together. It shows the examiner you aren't just thinking in isolated little silos. You are seeing the entire mathematical portfolio as one interconnected, dynamic system. It's a real game changer. All right, moving into Section 2, Executing the Procedural Framework. We have established the underlying theory, now let's talk about exact execution. This is your method mark strategy put into actual practice.
Let's run a quick mental audit. Imagine you have a 60-second visual timer ticking down. Before you even touch your pen to write an equation, data interpretation is absolutely critical. Under strict exam time constraints, you must extract the highest value insights from the text blocks or charts rapidly. You have to interpret the physical relationships and evaluate the quality of the evidence. This requires a rigorous risk assessment on your part. You need to ask yourself, what are the limitations here? What assumptions are being made about, say, friction or air resistance? What alternative interpretations could drastically impact your final evidence-based conclusion? That exact level of critical analysis is what commands true authority on the page.
And that rigorous risk assessment builds directly into our standardized sequence for problem solving. Think of this as your Peel formatting matrix, but engineered for mathematics. We call it the Deconstruct, Solve, Evaluate framework. Step 1. Deconstruct the question and clearly identify your given data points. Step 2. Select your analytical framework and apply the relevant principles, like F equals MA. Step 3. Execute logically, and I mean with absolutely crystal clear notation. Step 4. Verify your results. Please do a quick reality check for reasonableness. Ask yourself, does a 5-kilogram wooden block really accelerate at the speed of light? Probably not. And finally, Step 5. Present your findings with justified structural recommendations. This isn't just math, folks. This is a highly optimized operational workflow.
Now, let's contrast a weak pitch with a strong one. A failing analysis, our consultant Alex's approach, just states an equation and throws a jumble of numbers at the page. It's completely lacking syntax. A high-scoring analysis, however, aligns perfectly with our structural matrix. You state your point, you show the concrete mathematical evidence, you explain the mechanical assumption, and you link it back to the final context of the client's question. You identify similarities and differences, you use precise comparative connectives, and you back up absolutely every claim with hard mathematical evidence. Now we're going to pause the slide deck for a quick mid-masterclass mandate. To ensure your academic portfolio remains highly competitive, subscribe to our channel Ace the Exams at Ace-the Exams and enable notifications for our weekly consulting insights.
Okay, let's resume. Welcome to Section 3, the top 3 examiner traps. We have spent this time playing offense, now it's time to play some defense. We've audited the principal examiner reports, and we are going to look at the exact risk areas where a sample answer completely loses its structural credibility.
We're counting down the top 3 critical mistakes pulled directly from the actual Cambridge examiners themselves. Let's see what they are.
So the crucial point here is knowing exactly how to deploy the fix for each of these traps. Let's run a live diagnostic. Trap number 1, using the wrong approach for the context. The fix, you rigidly apply that deconstruct, solve, evaluate mantra we just talked about to ensure your mathematical model actually fits the real-world scenario. Trap 2, forgetting format and presentation. This is where answers lose credibility fast. The fix follows strict presentation conventions. Your answer shouldn't look like a frantic scratch pad. And trap 3, providing generic, non-specific answers. The fix for this one? You must tailor your mathematical evidence and your final statements specifically to the context given in the prompt. Absolutely no boilerplate responses allowed in this boardroom.
I really want to heavily emphasize trap number 2 for a second. Listen to me. Presentation is not just an aesthetic choice. It's not about making it look pretty. It is a strict compliance convention required to secure your full methodology points. Proper headings, correct terminology, again, distinguishing away from mass for sure, appropriate formatting, and crystal clear annotation. This is the bridge between a messy, confusing scratch pad and a brilliant executive summary. If the examiner cannot seamlessly trace the lineage of your logic from start to finish, they literally cannot award you the method marks. Your paper must look like a polished, finalized, high-scoring draft.
Which brings us to the close of our boardroom pitch today. Here is the Executive Framework Summary Checklist, wrapped up in one final provocative diagnostic question for you. Will you secure the method marks when it matters most by showing your exact deconstruct, solve, evaluate process? The very next time you sit down with a past paper, I want you to treat it like a high-stakes client proposal. Don't be an Alex, don't be a Sam, be the managing director of your own exam. Now, if you want to keep elevating your structural strategy and crush these papers, I have an absolute call to action for you. Subscribe to AC Exams at AC Exams, hit that notification bell right now, and comment below with your current exam level and your target subject. Keep practicing, keep optimizing your process, and I will see you in the next masterclass. Class dismissed.